Hi everyone, we are from Group 8 and today we are going to share with you some fun facts about the fermentation process in ethanol production. Let's go! Before we start, I would like to introduce my team. Starting from the left, we have Ikram, then Ehsan, and me Shabil. On the right, we have Afif, followed by Naim.
Bismillahirrahmanirrahim. Assalamualaikum, and my name is Afif. So in this section, we will evaluate the ethanol production process from corn stover. The process begins with pre-treatment, where corn stover is ground using a hammer mill and treated with calcium oxide. This breaks down the plant tough structure to expose fermentable sugar. Next is simultaneous saccharification and fermentation, where enzymes break down cellulose into glucose and yeast convert it directly into ethanol. The final step is purification, using molecular sieve to remove water and produce high purity ethanol. However, this step consumes up to 80% of the total process energy, making it one of the most costly. So the last one, there is a fun fact about this presentation where using Okay, next we're gonna go to challenges and efficiency in ethanol formation. So in this slide, there are several challenges exist. First, pretreatment is energy intensive. Second, ethanol can inhibit enzyme activity, which at 30 grams per liter cellulose activity drops by 25%. Also, there's a temperature conflict, which the enzyme prefer around 50 Celsius, while yeast is preferred 30 to 35 Celsius. So the process is run at a compromised temperature of about 38 Celsius. From a numeracy point of view, the process input 57 tons of corn stover per hour and produce about 16.9 tons of ethanol, which giving a conversion efficiency of nearly 30%.
Guys, do you know how is ethanol made? I will explain to you guys several steps of it on the next slide. So guys, this is how the ethanol is produced. First, corn is ground into a fine powder called meal. Then the corn meal is mixed with processed water and also enzyme. It's heated around 185 Celsius. And then we cool the mixture until about 93 Celsius and it's ready for the next step. Yeast is added. This process is called fermentation, which is carbon dioxide is produced and converts sugar into alcohol. It takes about 52 to 62 hours. And then they produce beer that 17 until 18% of alcohol. And then to the distillation column, it is heated until produce alcohol at 95 purity, and second distillation stage until reach 195 proof alcohol, and then to the condenser part where it cools the gas and turn into a liquid form. And then this is the last final product of ethanol, which 99% pure alcohol.
Let's talk about some key challenges in ethanol production. One major issue is mass balance inefficiency. During fermentation, not all the sugar is converted into ethanol. This means that some of the available raw material like glucose remain unused. Another big challenge is energy consumption. Distillation and dehydration are the most energy-intensive steps in the process. They require a lot of heat to separate ethanol from the fermentation proof, and even more energy to remove water and reach full grade purity. So both incomplete sugar conversion and high energy use are important issues that affect the efficiency and sustainability of ethanol production. Let's look at easy example. Imagine we start with 1000 kg of glucose. The more ethanol we can get from 1 kg of glucose is about half a kilogram. So 1000 kg of glucose can give us about 510 kg of ethanol. It is the best possible amount. But in real life, we don't get all of it because of some loss. If we can get 90% of the best amount, then we actually produce 459 kg of ethanol. That means we lose about 51 kg of ethanol during the process. On average, it takes about 3 megajoule of energy to make 1 kg of ethanol. If we make 459 kg of ethanol, the total energy need for distillation is equal to 1,377 megajoule. If we save 50% of that energy, for example by using heat recovery, this means the new energy use is 1,377 multiplied by 85%, which equal 1,170 megajoule. So the energy saved is 207 megajoule.
First, for Islamic perspective, wear your beautiful apparel at every time and place of prayer. Eat and drink, but always not by excess, for Allah love non-believers. So simply, Islam strongly emphasizes responsible, and wasting raw material like glucose contradicts will a grain producer to optimize fermentation efficiency. For second one, all believers in toxins, gambling, indoors and drawing lots for decision are all avid of Satan's handwork. So, the fermentation process must be carefully managed to avoid producing intoxicating beverages, which are prohibited.
Now, let's go to my part, which is suggestion for improving the process. The first one, we can make the process more efficient, such as we can use the better yeast that can produce more ethanol faster. We also can keep the temperature and pH at the best level for yeast to work well. Then, we can use a continuous system instead of batch because it can save time and increase the outputs. Second, be more sustainable. We can use waste material like sugarcane, leftover or corn stalks instead of food crops. This can help reduce the waste and does not affect the food supply. Then, we can reduce the waste. Reuse the CO2 produced during the fermentation in other industries like farming. It also, leftover yeast can be turned into animal feed or fertilizer. And the last one, follow the Islamic values. We can make sure material used are halal and clean. Using ethanol also can use for fuel or medicine is permissible in Islam. And the last one, saving energy and reducing waste supports the Islamic values of sustainable and responsibility.